That is part of GOC. Okay, so today's topic is amines. So amines are derivative of ammonia. If we replace one hydrogen by alkyl group, that is called primary amine. If we replace two hydrogens of ammonia by alkyl groups, that is called secondary amine. And if we replace all the three hydrogens of ammonia by alkyl groups or aryl groups, so that is called tertiary amine. So if we see their nomenclature, let us say we have this one. So its IUPAC name is methenamine. If we replace one more hydrogen by methyl group, it is called N-methyl methenamine. And if we replace other hydrogens as well, so it is called NN dimethyl methenamide. So in this way we can write the nomenclature. For example, if we have this compound, so what is the name of this compound? Yes, so the one which has more number of carbons, that is taken as parent chain, and other one as a substituent. So it is N-methyl ethanamide. So what is the name of this compound? So it is propane 1-amine. And if no, because if we have so both are propanamine actually, but one is propane 1-amine, other one is propane 2-amine. So in short, both are propanamines because both of them have 3 carbons, and one NH2 group. So both are propanamines, but position of NH2 is different. So they are actually isomers, structural isomers, and in particular they are position isomers, right? Now if we have this molecule, it is called N-methyl propane 1-amine. Okay, what is the name of this compound? It is aniline, or aniline is actually IUPAC recommended name, but its actual name is benzenamine. Good. So both are can be written as IUPAC name. Yes, it is IUPAC recommended name. That's why it is taken as IUPAC name. So what is the name of this compound? It is NN dimethyl aniline or NN dimethyl benzenamine. So it is NN dimethyl now preparations. So to prepare amine first from nitro compounds. So to prepare amine from nitro compounds, we use either catalytic hydrogenation or we can use Fe plus HCl or SNF plus HCl. And if it is nitroalkane, we can use lithium aluminum hydride as well. But on safer side, we use these three mainly. So we get our NH2. Means to convert NO2 into NH2, we will always use these three. Either it is aromatic or aliphatic. This is simply reduction of nitro compounds. But out of these three, FeHCl is preferred. So why there is a preference for FeHCl? No. Actually, whenever we have RNO2 and we use Fe plus HCl, there is a formation of RNH2 along with H2O. So now actually what happened, Fe when react with HCl, we get FeCl2 along with, actually this is the iron used here is scrap iron, which is not very costly, it is very cheap material. So we get hydrogen to reduce nitro compound. Now as water is formed, FeCl2 form gets hydrolyzed by this water and we get back HCl. So HCl used during the reaction is recovered. So only the chemical which is utilized is only scrap iron. So it is economical process because scrap iron is very cheap material. Okay. So this is the best method to prepare amine from nitro compound. So keep in mind there are three reagents main: H2PD, FeHCl and SnHCl. Second is by using, if we have let us say alkyl halide, and we react it with ammonia. You know, in Rx, X is negative, R is positive. So we get this salt, and when this salt is treated with NaOH, we get primary amine along with NaX and H2. So primary amine is formed as the major product if ammonia is in excess. So this is the condition applied, that to get primary amine as the major product, we should use ammonia in excess so that all the alkyl halide is used up. But if we have another case, if Rx is in excess, then you know, after reacting with ammonia, amount of Rx, small amount of Rx left behind, and therefore it further react with primary amine and we get secondary amine. If it is left again, we get tertiary amine, and at the end we get quaternary ammonium halide. So this is the disadvantage of this method. In this ammonolysis of alkyl halide, we get, this is ammonolysis. In this case, we get mixture of amines, means primary, secondary, tertiary, even quaternary, if alkyl halide is in excess. So to control the reaction up to primary amine, to get major product as primary amine, we should use ammonia in excess. Even if it is taken in excess, we get other products as well to small amount, because whenever primary amine is formed, there is a competition between primary amine and ammonia to react with alkyl halide, because both are present in the same container. So we get mixture of product and they are difficult to separate. That's why this is a disadvantage of this particular method. Now next is reduction of nitriles. So nitriles, because you know nitrile is formed by this method. Alkyl halide react with alcoholic ACN, we get RCN, alkyl nitrile, and then on catalytic hydrogenation or even lithium aluminum hydride or sodium amalgam and ethanol. These are the three reagents which are used to convert nitrile into amine. So this method is used to step up, because you know alkyl halide has, let us say, R group, and in cyanide there is one more carbon, and in amine again there is one more carbon than alkyl halide. So whenever more means amine is formed with one carbon atom more than the alkyl halide, we will use this method. So this is to step up, this is used to step up series. Okay, and next is reduction of amides. Now amide is CONH2. So amide can be converted into amine by using lithium aluminum hydride followed by hydrolysis. No, NaBH4 is used particularly for aldehyde and ketones. Sodium borohydride is a mild reducing agent and lithium aluminum hydride is strong reducing agent. Why is it so? Why sodium borohydride, lithium aluminum hydride is widely used even to reduce nitro compounds? That I said, because nitro compounds, here we can use lithium aluminum hydride. In nitrile even we can use lithium aluminum hydride. For amide we are using lithium aluminum hydride to reduce esters, carboxylic acids. We can use lithium aluminum hydride. But for sodium borohydride we mainly use it for aldehydes and ketones, to reduce aldehyde and ketones. Both are used for them, but sodium borohydride can be used for aldehyde and ketone. Why is it so? Because you know, if we compare BH bond and ALH bond, they are reducing agent because they give H negative. So you know, aluminium is larger in size than boron, so BH bond is strong bond. So we cannot get H negative ion as easily as in aluminum hydride, because this is a weak bond, because aluminum is large in size, so it can break easily, right? Which one? Alcohols. It is like, say, if we have alkyl halide, aldehyde, and we use sodium borohydride, we get CH2OH, we get primary alcohol. Okay, so in this case we get primary alcohol, and if we have ketone, we get secondary alcohol. Aldehyde give primary alcohol, ketones give secondary alcohol. Okay, now come to the next part. Gabriel phthalimide synthesis. So Gabriel phthalimide synthesis, you know, we start with phthalimide. Now phthalimide, when treated with alcoholic KOH, you know, CO groups are withdrawing groups, so they withdraw electron from nitrogen. Nitrogen in turn withdraw electron from hydrogen, and therefore there is an acid base reaction and we get N-alkyl phthalimide. Now this N-alkyl phthalimide react with alkyl halide. It is partial positive, it is partial negative. So we get an alkyl phthalimide. Here we cannot use aryl halide. So why we cannot use aryl halide? Because aryl halide, in aryl halide halogen will form double bond character due to resonance, and therefore it is difficult to break. So Gabriel phthalimide synthesis is used on hydrolysis. We get sodium salt along with primary aliphatic amine. So this method is particularly used to prepare primary aliphatic amines only. Primary aromatic amines cannot be prepared. So this is important because it is used to prepare only primary aliphatic amines. We cannot use it to prepare primary aromatic amines because aryl halides are less reactive, because CX bond acquires double bond character due to resonance. Now next one is Hoffmann bromamide degradation. This is used to step down. This is for step down series, means to decrease the carbons. Earlier, yes. So alkyl, there is a amide group. Amide react with Br2 and NaOH. So we get, even KOH can be used. So CO group is removed and we get NaBr and Na2CO3 plus H2O. So CO group is completely removed, and this is done by this shifting of alkyl group to nitrogen. This alkyl group with its electron pair shift to nitrogen, and therefore we have, means up to this, and we will keep in mind that in Hoffmann bromide degradation means decrease. So by bromination we decrease the number of carbon atoms. So this method is used for the step down of series, and KCN is used to step up the series. So these are the methods used. Now alkylation of amines. So alkylation is similar, which we have used earlier, that we use alkyl halide to react with primary amine. So we get secondary amine, and further reaction same, just like ammonolysis of alkyl halides. So we get tertiary amine and so on. So this is method used for alkylation. We use alkyl halides. And for acylation, this is ammonia. If we use acid chloride, you know, this lone pair will attack on carbonyl carbon. So we get this product, nitrogen with positive charge. So NH bond break to, at the same time this pi bond shift towards it, so we get RNH COR. Even we can use acid anhydride, acid chloride as well as acid anhydride can be used for the acylation. Yes, instead of Cl there is a removal of OCOR. HCl is removed, in that case carboxylic acid is removed. Now if we have nitro groups, nitroalkane and electrophilic substitution, we have aniline. Now aniline, you know, it is NH2 group has plus R effect, so it is activating and ortho-para directing. So aniline, if we do its bromination, what is the product formed? So actually NH2 is very activating group, highly activating group, and therefore bromine gets attached to all the three positions. We get 2,4,6 tribromo aniline. So if we would like to form only monobromo aniline, so first of all we do acylation either by CH3COCl or by using CH3COOCOCH3, either by acid chloride or by acid anhydride. So we get NHCOCH3. So if we attach COCH3, there is cross conjugation. What do you mean by cross conjugation? That lone pair can resonate from both ends. See, we have lone pair of nitrogen, so it can show resonance towards CO as well as towards ring. So effect of lone pair decreases, because in aniline it has only one option. It should donate electron to ring only. So here its activating influence is high. But when we attach COCH3 group to it, its activating influence decreases, first of all. At the same time, it has hindrance, steric hindrance at ortho position, and therefore if we do bromination in acetic acid, we get para product only. And which on acid or base hydrolysis we get 4-bromo aniline. That is the product formed. So this is electrophilic substitution reaction of aniline, and first one is bromination. If we use bromine water, we get 2,4,6 tribromoaniline, and if we would like to form 4 bromoaniline only, then first of all we should decrease the activity of NH2 group by attaching a acyl group to it, which will decrease the activating influence of nitrogen. Lone pair is distributed both sides, and that's why its activating influence decreases. And then on bromination only it attaches to para position, because on ortho position there is hindrance because of bulky group attached to it, and therefore H plus or OH negative ion, when hydrolysis takes place, we get back NH2. Next is nitration. So when aniline undergoes nitration in the presence of concentrated H2SO4 and concentrated H2SO4, we get 3 products: paranitro aniline, orthonitroaniline. You know, this is these 2 products are expected product, and there is a meta product as well. So para product is 51%, and surprisingly meta product is 47%. Para product is 51%, means it is almost same as that of para product, and ortho product is only 2%. So actually NH2 group is ortho para directing, so means ortho and para product should be major and meta product should not be formed. So meta product formed to such a large extent, what is the reason behind it? Actually, you know, HNO3, H2SO4, both are strong acids, and aniline is a weak base. So aniline react with this H plus ion due to the acids, and therefore it form anilinium ion. And you know, anilinium ion is electron withdrawing group, it is deactivating group. Okay, and therefore it is meta directing. So it form meta product due to the formation of anilinium ions. Keep in mind. Now next is sulfonation. So when sulfonation takes place, you know, aniline when react with H2SO4, you know, acid and base reaction takes place. So we have anilinium hydrogen sulfate, and when this anilinium hydrogen sulfate, because it is acid base reaction, simple, NH2 group, it is a aniline is a weak base, H2SO4 is a strong acid, so acid base reaction takes place, we get this salt, and when it is heated at 453 to 473 Kelvin temperature, we will get sulfonilic acid. So you know, NH2 and SO3H, there is acid base groups, and we get Zwitter ion structure. This is sulfonilic acid. We get Zwitter ion, or we can say dipolar ion. Yes, that's why it has high melting point. So question may be asked, during sulfonation of aniline, we get sulfonilic acid which has a very high melting point. Why is it so? So it is due to the formation of a zwitterion or dipolerion. That's why it has a ionic bonding, and you know ionic bonds are strong. That's why its melting point is high. Now surprisingly, aniline NH2 group is highly activating group, but it cannot undergo, or aniline does not undergo Friedel-Crafts reactions, Friedel-Crafts alkylation and acylation. So being highly activating, it should give all the reactions: electrophilic, substitution reaction of benzene, that is halogenation, that aniline do, nitration, aniline and derivatives do these reactions, sulfonation, but aniline does not undergo Friedel-Crafts alkylation and acylation. So why is it so? It is because, you know, when we use Friedel-Crafts alkylation, we are using Lewis acid, particularly anhydrous AlCl3 is used as a catalyst. So that catalyst is acting as catalytic poison here, because there is acid-base reaction. Aniline act as a base, AlCl3 anhydrous act as an acid. So there is a formation of salt, and due to the formation of salt, nitrogen of aniline gets positive charge and it becomes deactivating group instead of activating. So AlCl3, which is going to be used as a catalyst here, that is acting as catalytic poison for aniline, and that's why it does not undergo Friedel-Crafts reactions. Now Diazonium salt. So aniline, when it is treated with, means whenever we have to remove, we are going to remove this NH2 group, it is very difficult to remove NH2 group, because you know there is a double bond character between nitrogen and carbon due to plus R effect of nitrogen. So to remove it, we use diazotization reaction. Either we write NaNO2 plus HCl, or simply sometime we are writing HNO2, or and at 0 to 5 degrees Celsius. So there is a formation of N2 positive and Cl negative. Benzene diazonium chloride is formed, or simply we will write it as N2Cl, that is called benzene diazonium chloride. And aniline, when converts into benzene diazonium chloride, there are series of reactions. We can replace this group by chlorine, CuClHCl, CuBrHbr, CuCnKCl. Yes, this is Sandmeyer reaction. We get chlorobenzene, we get bromobenzene, even we get cyanobenzene. And you know, cyanobenzene, if it is hydrolyzed, we get benzoic acid. If it is reduced, we get benzylamine. Okay. If we get amide, and if amide is treated with Br2 and KOH or Br2 and NaOH, we get back aniline. So these three reactions, chlorobenzene, bromobenzene, cyanobenzene, this is Sandmeyer reaction. These are Sandmeyer reactions. Now on the same line, we can treat it with CuHCN and CuHBr. So we get chlorobenzene and bromobenzene, and these are Gaterman reaction. But if we compare the yield, you know, in Sandmeyer reaction we get chlorobromobenzene. In Gaterman reaction we get chlorobromobenzene, but in Gaterman reaction yield is poor as compared to Sandmeyer reaction, because here we are using metal, but in Sandmeyer reaction we are using metal salt. That's why yield is poor in Gaterman reaction and it is good in Sandmeyer. Now diazonium salt can be hydrolyzed to get phenol. Even to remove diazonium ion, means to get benzene from diazonium salt, we treat it with either H3PO2 or ethanol. So if we treat it with, this is called phosphorus, hypophosphorus acid. So we get benzene along with H3PO3 along with N2 and HCl. Here we get main products benzene and CH3CHO. So whenever we use H3PO2 H2O or ethanol, we get benzene from diazonium salt. So that means from aniline, NH2 can be removed completely, first converting it into diazonium salt and then treated with H3PO2 or ethanol. So next is to get fluorobenzene. First we treat it with HBF4, we get N2BF4 negative, which on heating gives fluorobenzene, BF3, N2, and this reaction is called Basicity reaction. This is given in the NCERT, but name is not mentioned. Now again, if this N2Cl on treating with HBF4, first we get this product N2BF4 4 and we treat it with Cu and NaNO2, then we get nitrobenzene. We get nitrobenzene. Now, if we have nitrobenzene, this is the nitrobenzene. If we treat it with phenol or beta naphthol, then so say in this case what happened, you know, OH group is ortho-para-directing, and because say phenol is acidic, so we use base, means we use pH 9 to 10, weakly basic medium is used. Actually this one, this is the electrophile in this reaction, and you know this is a we can say a bulky electrophile, so it will attack on the site where hindrance is less. So para is the target position where it can easily attack. So that's why we get para-hydroxyazobenzene. So question is why we use weakly acidic medium, sorry, weakly basic medium. Actually, say phenol is more reactive when it is in the form of phenoxide ion. So if medium is basic, the formation of phenoxide ion is easy because H plus ion is removed. So why not make it strongly basic medium so that all the phenol is in the form of phenoxide and reaction is fast? Because if we use strongly basic medium, that will excess of OH negative ion will attack on this electrophile, and therefore electrophilic nature of this molecule is destroyed, and therefore we use weakly basic medium so that we get phenol in the form of phenoxide ion, but at the same time this electrophile remains as such to attack on para position. So this is para-hydroxyazobenzene, which is orange dye, and aniline. So if we have aniline, aniline is a base, so we use weakly acidic medium, because to use this weakly acidic medium, if we use strongly acidic medium, you know, aniline will no more activating. What happened to aniline? It become anilinium ion. That's why we use weakly acidic medium, and we get para-amino azobenzene. yellow dye. One is orange, other is yellow. See, orange we can take it from O, and other one is yellow. So these are the dyes formed. Now okay, we forget to write few more reactions like carbylamine reaction. कल मैं थोड़ी देर कर मैं जरा क्लास आ जाए है ना, मैं क्लास आ जाए. ओके, मैं थोड़ी देर ठीक ठीक ठीक. ओके, carbylamine reaction. So carbylamine reaction is used to test only primary amines. So this is primary amine along with chloroform and CUET or NaOH. So we get isocyanide, which is foul smelling substance. This test is used for primary aliphatic as well as aromatic amines. It is a test for primary aliphatic as well as aromatic amines. So we get isocyanide along with NaCl and H2. Okay. Secondary and tertiary amine do not give this test. So to test all of them we use Hinsberg reagent test. And what is Hinsberg reagent? It is benzene sulfonyl chloride. So benzene sulfonyl chloride is called Hinsberg reagent when we treat it with primary amine. Then HCl is removed. We get N-alkyl sulfonamide. Now in N-alkyl sulfonamide, you know, there is an NH bond. There is a hydrogen atom. First primary amine react with benzene sulfonyl chloride because there are NH bonds. After reaction, even then there is an NH bond which is highly acidic, and therefore it is the product formed is soluble in alkali. But when we have secondary amine, first reaction can take place because there is H bond, H group, NH bond is there. So it will react with benzene sulfonyl chloride, but after reaction there is no NH bond, and therefore it is insoluble in alkali. And if we talk about tertiary amine, this is secondary amine. Tertiary amine, in tertiary amine there is no NH bond. So no reaction takes place. So in this we can distinguish between primary, secondary and tertiary amine by using Hinsberg reagent. So primary amine react with Hinsberg reagent and product formed is soluble in alkali. secondary amine react with amine Walsh-Kieman reaction, secondary amine react with Hinsberg reagent, but product formed is insoluble in alkali. Tertiary amine, no reaction. With diazonium, this NaNO2 and HCl, if we have aliphatic amine, then diazonium salt is highly unstable. So water formed in the reaction hydrolyze it and we get alcohol as the product. But in case of aniline, we see whenever we have NaNO2 and HCl, we get diazonium salt, which can be used to prepare so many products. If we have secondary amine, then we NaNO2 HCl, instead of that we can write HNO2. So in that case we get N-nitroso product. And if we have like N-dimethyl aniline, so in that case we get product like this. I think that's all about the reactions. Now okay, this is reaction, means one of the question. 1 mole of a compound X reacts with 1 mole of benzene sulfonyl chloride, that is Hinsberg reagent, to form the compound Y. So compound X react to give compound Y. The compound Y is not soluble in an alkali. So which one is the compound X? First one is primary amine, second is secondary amine, third is primary amine, and fourth one is tertiary. So you know, according to Hinsberg reagent test, primary amine react with Hinsberg reagent and product formed is soluble in alkali. Secondary amine react with Hinsberg reagent and product formed is insoluble in alkali. So that means secondary amine is the right option. Next, the correct statement or statements. This can be more than one option. Right. Regarding the basicity of amines is. So order of basic strength of methyl substituted amines in aqueous solution. We have already done this question in the previous lecture.
Yes.
So is it correct or wrong?
Wrong, sir. It is okay. First, sir, accessibility of the
Yes, if it is methylamine, in methylamines, you know, secondary, primary and tertiary. In ethylamines, it is secondary, tertiary, primary. So that means this is correct, because it is secondary, primary and tertiary. Next is solvent stabilization of the conjugate acid of dimethylamine in aqueous solution is more than that of the conjugate acid of methylamine. Is it correct or wrong? The question is solvent stabilization of the conjugate acid of dimethylamine and conjugate acid of methylamine. Which one is more stable? See, actually it is about hydrogen bonding. We have already done it, that if we have dimethylamine, so what is its conjugate acid? Its conjugate acid is like this, right? Along with OH negative. So there is a formation of two hydrogen bonds. But when we have methylamine, you know, which one has stronger hydrogen bonding? So that means methylamine forms stable conjugate acid, because stabilization is more of methylamine rather than ethylamine. That means this statement is wrong. Got it? Now third one, again it is secondary, tertiary and primary. That's right. Okay, out of cyclohexylamine and aniline, which one is stronger base? In cyclohexylamine, nitrogen lone pair is intact and ready for donation, but in case of aniline, lone pair is less available on nitrogen because it is involved in resonance, and that's why cyclohexylamine is stronger base. So that means, so 1, 3 and 1, 2 and 3, sorry 1, 3, 1, 2, 1, 3, 4. So statement 1, 3 and 4 are correct. Yes, the correct statements based on the reaction scheme given below. So first of all, what is P and NaOH Br2 means? Which reaction is taking place? Yes, it is Hoffmann bromamide degradation reaction. So obviously this compound should have CONH2 group. So if we remove CONH2 from this C7H7NO, what is left? So that means it is benzamide. So when we treat it with NaOH and Br2, what we get? We get aniline. So that means this is P, this one is Q. Now when this Q is treated with NaNO2 and HCl. So NaNO2 plus HCl, that will give diazonium salt. Now when diazonium salt is treated with water, we get phenol, right? So it is P, Q, R and S. So first statement is, you have to write the correct statement or statements based on the reaction scheme. So compound Q can be reacted with R in the presence of base to form a dye. Is it correct? Because it is azodye test. We have done just now the diazonium salt when treated with aniline. Sorry, when diazonium salt is treated with aniline in the presence of a base. Yes, in aniline we use some but weakly acidic medium, but anyhow, as it is written as dye is formed. The compound Q is basic and S is acidic. Compound S can be reacted with R in the presence of a base. Actually, here it is. So means first statement is wrong. Compound P and Q have the same number of carbon atoms. Wrong. That means statement 2 and 3 are right. Okay. Here only simple, if it is written as acid, it's true. Aniline. Physical properties of a? Yes, so simple. In physical properties, we will just see the boiling point, solubility. So if we compare boiling point, see if we have CH3, CH2, CH2, NH2, we have CH3, CH2, NH, CH3 or CH3 and this is primary, secondary and tertiary amine of comparable molecular masses. So boiling point of primary amine is more than secondary, which in turn more than tertiary. Why is it so? Because in primary amine there is more number of hydrogen bonds than secondary and tertiary. Same is the order of solubility. Primary amine is more soluble than secondary than tertiary because primary amine can form more number of hydrogen bonds with water. So this is the only two topics under the heading of physical property. Yes, boiling point and solubility both have same order. Solubility in water and boiling point of amines. And if we see the case where branching takes place. So that you know, if there is a branching, what happened? Boiling point decreases, and so is the solubility, because this NH2 is now attached to carbon, which is more hindered. So that's all. There are few questions, like I think we will cover it in the next lecture. We will do first there the means MCQs related to amines. Next, same topic. We will do same topic. Okay. What? Okay, I will say. Good night. Okay, so thank you so much to all of you. If you have any doubt, please do ask. Have you any doubt, beta? So see you after on Thursday. Same time, 8 o'clock. मैकेनिज्म बेटा, किसका मैकेनिज्म? मैकेनिज्म ऑफ किसका बेटा? किस रिएक्शन का मैकेनिज्म? बेटा मैकेनिज्म, दो रिएक्शन का मैकेनिज्म इंपॉर्टेंट है, एक हाइड्रेशन ऑफ एल्कीन टू अल्कोहल और डिहाइड्रेशन ऑफ अल्कोहल टू एल्कीन। ये दो मैकेनिज्म आपको करने हैं मेन, ठीक है? ओनली टू रिएक्शंस मैकेनिज्म इज इंपॉर्टेंट। ठीक है? लोक कुमार, गॉट इट? यस, ये नेस्ट के ही क्वेश्चन थे बेटा रविराज। ये जो मैंने 3 क्वेश्चन लिए आज, ये नेस्ट के ही क्वेश्चन थे। ठीक है, ये क्वेश्चन नेस्ट के ही थे बेटा। वी विल डू दोज क्वेश्चंस जो भी टॉपिक में आएंगे। जैसे आज एमीन्स का टॉपिक था, मैंने और क्वेश्चन भी लिए हैं, तो नेक्स्ट क्लास में मीन्स थर्सडे को होगा। मैं थर्सडे फ्राइडे सैटरडे मैंने क्लास रखा है ना, तो तब हम वो क्वेश्चन बाकी करेंगे। जैसे नेक्स्ट है CUET भी है, सेंट्रल यूनिवर्सिटी के एग्ज़ाम है ना, उनमें भी ऐसे क्वेश्चन आते हैं। ओके, चलो बाय बेटा।